If your PKI diagram disappeared tomorrow, could your team still explain how trust actually flows? In this module, we'll turn fuzzy mental models into precise visuals that expose risks, align stakeholders, and serve as the living blueprint for your PKI. When you design PKI, it helps to work deliberately in three complementary views. The logical view shows conceptual trust boundaries. Here you care about roles and services, which CAs, RAs, HSMs, and directories exist, and which of them actually trust each other. The physical view ties that model to real infrastructure. This is where you decide which servers, clusters, and HSMs run those roles, and where they sit across data centers, DMZs, and cloud regions. The behavioral view adds time. It shows enrollment, renewal, and validation as sequences of messages. Throughout this course, we'll move consciously between these views, and we'll consistently mark external public CAs to make those critical trust boundaries obvious. You can think of PKI as having trust gravity. The root CA is the trust anchor. Everything else orbits around it. It rarely issues certificates directly. Instead, it delegates to intermediate CAs that specialize in purposes like TLS, user authentication, devices, or code signing. Those intermediates then issue leaf certificates to actual endpoints, servers, devices, and users. Applications only see those leaf certificates, but they implicitly trust them, because that trust pulls all the way back to the root anchor. Bridge keys create side connections between otherwise separate hierarchies, extending this gravity into other organizations or ecosystems without sharing a root. Most enterprises don't live under a single trust anchor. Endpoints operate in a multi-anchor world. One trust anchor is your internal enterprise root, issuing certificates for things like corporate Wi-Fi, VPN, or internal web services. Another is an external public root, used for SaaS and internet-facing TLS. Each root has its own issuing CAs, and each chain must be fully valid on the endpoint, including access to OCSP responders and CRL distribution points. Designing PKI here means mapping scenarios to the right anchor, verifying that revocation checking works for each, and ensuring both sets of trust can safely coexist without breaking applications. A robust PKI design treats the CA hierarchy as layered security zones, not just a couple of Windows servers. At the outer edge, internet clients only reach hardened endpoints, web application firewalls, reverse proxies, OCSP responders, and CRL servers. These systems expose revocation and validation, but never direct access to issuing CAs. Deeper inside, in a high-security zone, online issuing CAs and registration authorities handle enrollment and approvals over tightly controlled internal flows. At the core, the root CA is isolated or air-gapped and used only for rare, highly scripted operations like signing subordinate CAs, minimizing blast radius if anything online is compromised. When you connect cloud-managed CAs or HSMs to an enterprise network, the first design task is to define traffic flows in detail. Security teams will ask, which systems initiate connections, on which ports, and in which direction. That applies to OCSP and CRL delivery, SEP or EST enrollment, CMP, RPC, and any management APIs. You also need clear controls around those flows. VPN or private link for transport, WAFs in front of exposed PKI interfaces, and bastion hosts for administrative access. If you can't hand your network team a precise port and protocol matrix, your PKI design isn't ready for implementation. PKI is a lifecycle engine that never stops running. It begins with enrollment. An endpoint or registration authority creates a CSR, identity is vetted, the CA issues a certificate, and keys may land in an HSM. Next comes validation. Clients build the chain to a trusted root, check CRLs or OCSP, and compare policies with their local trust store. Then renewal takes over. Automation or agents decide whether to reuse keys or rotate them, trigger ACME or other workflows, and enforce policy. Finally, revocation handles exceptions, pushing changes through approval workflows, CA processing, and OCSP, so relying parties can react quickly. You can view this lifecycle as two engines working together, but with different responsibilities. On the identity side, IAM systems handle proofing, HR-driven joiner-mover-leaver events, and access policies. They decide who should get what kind of credential and when that should change. On the PKI side, CAs focus on cryptographic operations only, issuing, renewing, and revoking certificates based on trusted inputs. The IAM-aware interface in the middle is where these worlds meet. Your design goal is strict separation. IAM proves and governs identity, while PKI enforces cryptography according to IAM's instructions and feeds back revocation and lifecycle events. When you diagram PKI, treat the diagram like source code for your future self and everyone else. Apply a strict naming convention for CAs, HSMs, networks, and zones so you can instantly see what a component does and where it lives. Always include a legend so colors, icons, and line styles each have one unambiguous meaning. Then separate flows. Distinguish trust path from normal network traffic and from admin access with clear direction arrows and labels. This hygiene feels tedious, but it prevents catastrophic misreadings during audits, incident response, and future redesigns. When you communicate PKI designs, you're really choosing between two lenses, not two different truths. For executives, stay at the trust and risk level. Focus on business impact. What sits inside the trust domain? What is outside the compliance boundary? Where risk concentrates? And how the design reduces the chance and blast radius of a PKI incident. For engineers, zoom into flows and specifics. CA placement, HSM usage, firewalls, protocols, and dependencies. Your job is to translate cleanly between these views so decisions, funding, and implementation stay aligned. Think of your PKI diagrams as a single story told in 3 layers. At the bottom, show where things physically live: data centers, HSMs, networks, and security zones. Above that, show the logical trust path: routes, issuing CAs, OCSP, and how chains are built. On top, show the behavioral IAM sequence: who requests a certificate, which policies apply, what approvals happen, and how the certificate is actually used. When these views line up for a single scenario, you end up with a master architecture portfolio you can reuse for onboarding, incident response, audits, and future design discussions.